So in section P.4, we're going to add and subtract polynomials. When we're given a polynomial that has addition or subtraction in it, we can only simplify by adding or subtracting if there are like terms within the polynomial. And this definition that I wrote up here, like terms are monomials that have the same variables with the same powers. And when we're dealing with adding and subtracting with polynomials, you can only add when you have like terms. So this would be an example of like terms. The terms 3xy squared and 7xy squared, those are like terms because they have exactly the same variable structures. They have the same variables and the variables have the same exponents. Like terms can be added, they can be subtracted. If I wanted to, I could add these like terms, like 3xy squared plus 7xy squared. And when you add like terms, only the coefficients get added, the variable parts stay fixed. So in this problem, the coefficients are 3 and 7, and 3 plus 7 adds up to 10. So adding those like terms, I'd get 10xy squared. Similarly, because these are like terms, they can be subtracted. I could do 3xy squared minus 7xy squared. And just like with adding like terms, when you subtract like terms, you're just going to subtract the coefficient and the variable part's going to stay kind of set. And 3 minus 7 is negative 4. So subtracting these like terms, I'd get negative 4xy squared. Only the coefficient changes when you're adding or subtracting. And in order to add and or subtract, you have to have like terms. These terms would be not like terms. And if I gave you like 3x and 5x squared, because they're not like terms, although they have the same variables, x's, the x's don't have the same powers. Like terms can't be added. So if I said to add 3x plus 5x squared, I'll write it in a nicer order, with the highest exponent first. If I asked you to add 5x squared plus 3x, you can't get 8 with some sort of variable after it. These can't be added. It can be rewritten by factoring. You could actually do something that we learn in chapter 1 and factor out a common factor, but they can't be added. If the instructions were to add the terms 5x squared plus 3x, those can't be added. So each of the first 16 problems is just a polynomial. In problem 1, that's a polynomial that has 6 terms, and we're asked to combine like terms, and because between the terms there's only adding and subtracting, I have to combine by adding and subtracting the like terms. And very specifically, I'm going to look at my problem. I'm going to gather the like terms next to each other with the highest degree term first, the lowest degree term last. I'm going to write the terms in descending order. I'm going to add or subtract the like terms. So if I was doing problem 2, I'm going to rewrite this. Addition and subtraction. Addition is commutative. I can rewrite this problem so that the like terms are next to each other. In this problem, the 8y cubed and the 2y cubed, because they have the same variables with the same exponents, are like terms. So I took those into consideration. And the 5y squared and the minus 4y squared are like terms because, again, they have the same variable with the same exponent. The 7y and the minus y, the positive 7y and the minus y, which is really minus 1y, are another set of like terms. And the constants, minus 2 and positive 11, are all like terms. So in this polynomial, there are 4 groups of like terms that can be added or subtracted depending on the signs between the terms. I'm just going to add or subtract the like terms, and when you add or subtract, only the coefficients change. So I'm going to combine the 8y cubed and 2y cubed. When I add the 8 and the 2, I get 10, and adding and subtracting, you just don't change the exponent, you add or subtract the coefficients. My next group of like terms, 5y squared minus 4y squared, that's going to give me a plus. 5 minus 4 is 1, plus 1y squared, and I probably wouldn't write the 1 before the y squared. I'll write it in a different color. You could have it, but it's not necessary. 7y minus 1y is positive 6y. And negative 2 plus 11, because those have opposite signs, I'm going to wind up subtracting. The negative 2 plus 11 is a plus 9. This would be considered combining like terms and writing the answers in descending order. So identified the like terms. That's the same variable structure. And then I combined by either adding or subtracting the coefficients. And my answer is written in descending order. I have an exponent of 3, an exponent of 2, an exponent of 1, and a constant term. I'll do the same for number 4. In number 4, the like terms I'm going to have are 12y cubed minus 2y cubed plus 5y squared minus, I'm going to emphasize 1y squared, even though the coefficient of 1 is not written, it's assumed. And then 3 first power terms, then minus 3y plus 11y plus 9y. So these are the groups of like terms that I'm going to combine. My final answer is going to be a trinomial. I'm going to have 3 terms. The first subtraction of 12y cubed minus 2y cubed is going to give me the term 10y cubed. And then 5y squared minus 1y squared is positive 4y squared. And then lastly, minus 3y plus 11y plus 9y. I can't do the y's on my calculator, but I can do the coefficients. So minus 11 plus 9. The coefficient of the y is going to be a positive 17. So to end up my answer, to get that trinomial, I get a plus 17y. So my answer to problem 4, I've combined all the like terms that can be combined, and I've written my answer in descending order, 10y cubed plus 4y squared plus 17y. 6 is going to be maybe a little bit harder because there's not as many like terms, but yet I need to combine what I can and write in a nice order. So if I look at problem 6, the highest degree term is the negative 4y squared. It needs to wind up in my answer. The square term needs to come first. It's not going to have a like term to combine with it, so I'm just going to ignore it. I'm going to move down to the y to the first power terms. The positive 2y, I'm going to put a plus sign in front of the y because it's positive, and the plus 3y. So I've dealt with those, at least I have these taken care of here. And then the plus 11. So when I go to simplify by combining like terms, this is kind of the order that I need to think of. I need to have the variables, the terms going in descending order, highest exponent to lowest exponent. I need to put the like terms next to each other and combine the like terms. The minus 4y squared, because it doesn't have a like term, just kind of goes first in my answer. The 2y and the 3y add to be 5y. And the 11 just tags along at the end. There's definitely other things I can do to this answer that we'll learn to do in chapter 1. But for now, this is all I'm asked to do. I combined like terms. I wrote the answer in descending order. It turns out, if you remember, if you learned factoring in another class, you can factor out a negative 1 and maybe turn this into a 2 parentheses factoring problem. I don't want to get there yet. Yeah, my problem 8 is harder than your number 7. So in number 8, fractions make it hard, but the fractions have the same denominator, so it's not so bad. When I do number 8, and I've lost the screen here. So that problem 6 that I did, it might have just blew off the screen. Let me real quickly talk about what I did. So I wrote the minus 4y squared first, the 2y and the 3y second, and then the 11. And then I just combined the 2y and the 3y. Those were the only like terms. Those combined to be 5y. I wrote the 3 terms in a nice order. When I'm moving down to problem 8, the terms that are the highest exponent terms, or the highest degree terms, are the 4/5 y and the 3/5 y. Those are like terms. Even though they have fractions for coefficients, the variables are both y to the first power. after the first power terms, I'm going to write the constants, the numbers without the letters, minus 2/3 and minus 1/3. Now I'm going to combine the coefficients to get the y term to have the correct exponent. If I'm cruddy at fractions, I could just go 4/5 plus 3/5. My calculator tells me that's 7/5. I prefer 7/5 to 1 2/5, so the coefficient of the y in my answer could either be 7/5 or 1 2/5. We usually don't write decimals unless we're asked to. But by hand, the adding was really easy. I needed to add the coefficients of the y, which are 4/5 and 3/5. And because those fractions have like denominators, I just added the 4 and 3 and left the 5 alone. The next two fractions, the constants that need to be combined, if I did this on my calculator, I'd have to first make a negative 2/3 by using the negative by the fraction, then the fraction key, and then 2/3, arrow out of the fraction, and then this is a subtraction. This is a negative sign in front of the 2/3, which is by the fraction. Between the negative 2/3 and the 1/3 is subtraction, which is that minus by the equal sign, and then fraction 1/3. So that should reduce to -1. So in my answer, I should have after the 7/5 y a -1. If I wanted to, it would look odd, but I could have written in my answer 7/5 y plus a -1. That would equally be good. If I wanted to do the fractions without my calculator, the negative 2/3 minus 1/3, because those two fractions have the same denominator, I could make the two fractions into one by writing their numerators next to each other, which is -2 and -1. The numbers in the numerator are both negative, so if I'm going to simplify these, I'm going to add the numbers and keep them negative. 2 plus 1 is 3, but -2 minus 1 is -3. I'm going to leave the denominator, and then -3 divided by +3, positive divided by negative is a negative, 3 divided by 3 is 1. That's how that gets to be -1. Both of these answers are fine, but this is more work to write it this way. I generally wouldn't write a plus a negative as opposed to writing a minus, although they're equal to each other. Few more of this style of problem, just with a single polynomial combining like terms. And if I was doing my problem 10, the first terms I'm going to worry about are the squared terms. So to simplify number 10, I need to combine the 3y squared and the 5y squared. I say first, at least they need to be written first. And then the grunge, the 1/2 y, the 2/3 y, and the 5/6 y. Before I write these terms over here, these 3y terms, I'm going to make them all have a denominator of 6, because when you're adding or subtracting with fractions, you have to have common denominators. So this first term, the 1/2 y, I'm going to multiply by 3/3. I'm going to multiply 3 times 1 and 3 times 2. And this is going to be a positive, because I need a sign here, and it's not negative, so I get a plus sign. And it's going to be 3/6 y. The next fraction, the -2/3, I'm going to multiply by 2/2. I'm going to leave the minus sign in front of that fraction. I'm going to multiply the 2 times 2 in the numerator and get a 4. I'm going to multiply the 2 times 3 in the denominator and get a 6. And I'm going to leave the y alone. The last fraction here, 5/6, is a good fraction. I'm going to leave that 5/6 y. I've dealt with everything except the +8. I'm going to tack that on at the end. So these are all the terms written in an order so I can combine. Now I'm going to combine the 3y squared and 5y squared, get my leading term of 8y squared. This is a second degree, it's going to be a trinomial. And then I'm going to work with 3/6 minus 4/6 plus 5/6. If you're cruddy with fractions, just rip them out on the calculator. I don't have an issue with that. My calculator tells me that the coefficient of the first power term should be a positive 2/3 y. To get that without my calculator, I'd need to worry about doing 3/6 minus 4/6 plus 5/6. And when I do that, I have to do 3 minus 4 plus 5 over 6, and 3 minus 4 plus 5 is positive 4. So this would come out to be 4 over 6, and 4 over 6 reduces to 2/3. I don't have issues with you doing fractions with your calculator if you're not comfortable adding and subtracting fractions by hand. And that will probably be the case in any class higher than this. It'd be nice to learn how to do the fractions by hand, but not such a big deal for us. We kind of assume you can do the fractions by hand if we forced you to relearn that skill, if you can't already do it. I'm going to bring down the plus 8, and my answer is going to be this trinomial of 8y squared plus 2/3 y plus 8. For problem 12, I have to be worried about the degree of the terms to get them written in a nice order. This first term, 2ab, the a and the b both have exponents of 1. I'm going to add those exponents, and that term's going to be a degree 2 term. The second term, the minus 3a squared b, the a has an exponent of 2, the b has an exponent of 1. I'm going to add those exponents. This is going to be a degree 3 term. The 5ab has the same variable structure as a 2ab, so that's also going to be a degree 2 term. And the ab squared term, oh gosh, it has an exponent of 1 on the a and 2 on the b. It's a 3rd degree term. So I'm going to write my like terms next to each other. And unfortunately, the only like terms I have are the 2ab and the 5ab. Those get to be written next to each other. These 3rd degree terms here, the minus 3a squared b and the minus 7ab squared, those can't be added or subtracted because although they have the same variables, the variables don't have the same exponents. I'm not really sure which of these to write first. Usually when we're simplifying a polynomial, we write the highest degree term first. But since we have a tie here, I can pick. I'm going to pick the a squared one to write first just because the a alphabetically has a higher exponent, but that's not really, there's no rule that says I need to do that. So I need to get this written in a nice order. The highest degree terms first, the lowest degree terms second. So I have the minus 3a squared b, which is a 3rd degree term, the minus 7ab squared, which is a 3rd degree term. These terms can't be combined by adding and subtracting because they don't have exactly the same variable structure, and then the 2nd degree terms. So a correct answer for this problem would be minus 3a squared b minus 7a squared ab squared, and these terms add up to 7ab. There's definitely no magic to my choice of writing the 3rd degree terms in the order that I did. It would be equally correct if I wrote minus 7ab squared as the first term and the minus 3a squared b as the second term, but the 7ab should tag along at the end, kind of regardless of your choice of which term to write first. Ugh. So real quickly in 14, I'm going to run through and catch to the degrees. This first term has an exponent of 3 on the x, 1 on the y. This is a 4th degree term. The second term has an exponent of 3 on the x, 1 on the y. That's a 4th degree term. The term with an exponent of x1 and y2 is a 3rd degree term. The 4th term has an exponent of 3 on the x, 1 on the y. I add the 3 and 1 and get this being a 4th degree term. And the last term is another 4th degree term. It's x to the 1st power, y to the 3rd power. I add the exponents and get 4s. I'm going to write the 4th degree terms first and group the like terms before the unlike term. So I have 3 like terms of 4th degrees. The 9x cubed y. I'll write an equal sign because what I'm writing is equal to the problem I was given. And the 11x cubed y. The 8x cubed y, or positive 8x cubed y. Those are 3 absolutely like terms that can be added into a single term. The next fourth degree term needs to be written up front before the third degree term, but I can't combine it with the fourth degree term. And then lastly, the third degree term of minus 4xy squared. I'm going to combine the like terms into a single term. I'm going to go 9 plus 11 is 20, 20 plus 8 is 28. And a correct answer, and probably the best correct answer, would be 28x cubed y minus 12xy cubed minus 4x squared y. You could flip-flop the first two terms, so I can write an or here. But I like my polynomials to lead off with a positive as opposed to a negative. So even though both of the first two terms in my answer are fourth degree terms, I probably would choose the positive to write first. But these are both completely acceptable answers. And this boxing is just what I'm combining. It's not the answer. One last problem, and then we'll pull and do a part 2, maybe a part 3 for this. So let me figure out the degrees and like terms, get this rewritten. First term, the x has an exponent of 1, the y has an exponent of 2, the z has an exponent of 1. That's a fourth degree term. The second term, each of the x, the y, and the z have exponents that are implied to be 1. That's a third degree term. The third term has the same, no it doesn't. The x has an exponent of 2, the y has an exponent of 1, the z has an exponent of 1. That's a fourth degree term. And then the last term, x has an exponent of 1, y has an exponent of 2, z has an exponent of 1. That's a fourth degree term. I'm going to write the fourth degree terms before the third degree term, and these two terms I'm going to write first because those are like terms. They have the same variable structure. So as I go to rewrite this, I think of this as 2/5 x y squared z minus 3/8 x y squared z. And then the last fourth degree term, minus 1/4 x squared yz. And then the third degree term, minus 2/3 xyz. These last groups of terms, that term and that term, are just going to be part of my answer. They're not like any other terms. They can't be combined. These terms are like terms. They can be combined, but I need to get common denominators for the fractions, and that common denominator would be 40. If I wanted to do this by hand, I'm going to make both fractions of the like terms have the same denominator. The terms that I'm not combining, I don't need to make their denominator equal to what I'm making the like terms. So first fraction, I'm going to multiply by 8 over 8 and get 16 over 40. Not changing the variables, x, y squared z. And then minus 5 times 3 is 15, 5 times 8 is 40, 15 over 40, x, y squared z. And then I didn't leave this so nice. And then minus 1/4 x squared yz minus 2/3 xyz. And now I just need to do 16 over 40 minus 15 over 40. That's going to give me 1 over 40. I just subtract the 16 minus 15 and get 1. So my first term that I'm going to write is 1 over 40 and then x y squared z. It's a fourth degree term. I need a fourth degree term to be first, and it has a positive coefficient. I like to write it first. The next fourth degree term has a negative coefficient, and I don't like to, if I have a choice between writing a positive term and a negative term, don't like writing the negative. So for my answer to problem 16, this would be nice. I can flip-flop the first two terms if I care to. All right, so I'm going to pause the video and we'll work into a part 2, maybe a part 3 because it's kind of a long section.